All right, welcome to this video. You were out today and you are being responsible in writing down everything from this video in order for you to do well on this test tomorrow. All right, numbers 1 through 6, identify whether each function is not, well, whether each is a function or not a function. So we know that a function is a set of ordered pairs. We're going to write this definition down. Function, set of, all right, man, of ordered. All right, this is not going to work. I have to go to my other software because we're not about to do this. Function, I was trying to do this to save so I can save on the paper. It's clearly not going to act right. Ordered pairs with no repeating x values. Oh yeah, your name goes right there. Everything I write, I expect you to write. Okay? So it's not going to be that hard. All right, so we look here, we see those two. If I underline something, then you underline it. So we know that these are not functions because the x value repeats. No. -2 repeats in x value. On your test, you will not have to write this explanation. I want you to write it down now. Here we have no, 1 repeats in x value. Let's look at number 3. All right, so we have this going to 1, going to 1, all right. Yep, yes. No repeating domains, which is the same thing as x values, y'all. None of these repeat. Here, well, look at there, look at there. You go there and there. You can't cheat. No, no cheaters. No cheaters. No. Domain repeats. You can't cheat. Get your life together. All right, let's slide on down the paper. Well, for me, slide on down. For you, just stay right there. Number 5, is this a function? Well, let's look at the x values. -1, 0, 1, 2, 3. Yes. No repeating x values. Number 6, is this? No. Look at that 4, cheating. Can't cheat on 7 with 14. No. The 4 repeats in the x value. All right, so as we scroll down for me and look down for you, when I look at number 7, so question to you, what test do we use to see if a graph is a function? I know you said it, I heard you. Use vertical line test. And if we use the vertical line test correctly, we'll take a vertical line that I'm going to draw. And no, you don't have to draw this because I'm going to manipulate this line to show that it's not a function. All right, so we take the vertical line and we say, hey, when you cross, I wonder how this looks. Oh, this looks really weird. Oh, wow, let me stop. It's acting weird. Oh my gosh, it's moving without me moving it. Probably because I have this pen tool on. So that's what I'm thinking. That's why I did it. It's still weird. All right, so I'm gonna slide. It's probably gonna slide all the way across the screen, but it's magic. So as we can see that here, I wonder how that looks in the video. I'll find out later. That the vertical line. Wow, totally missed that line, buddy. All right, there we go. It's supposed to be vertical. So technically, this line would have came straight down. You cross right here, shoot, and right here. So no. Fails vertical line test. That's how I know if you really did this, because you have VLT, because you wouldn't have that before. So if we come over here and use the vertical line, let the ghost, you drag the vertical line. Oh my gosh, look. Go through. No, pass. Almost made it through, y'all. Almost. And it passes. So, yes. Yes. passes the vertical line test. No. Fails. I know we had it. The vertical line test. I know we had it already, but whatever. All right, let's keep it moving. That's really weird. Miss Hindle buys a used boat. Her monthly payment plan is shown in the table. Month. Oh, I forgot to change the name. Oh, well, Brown was yesterday, and now it's still supposed to be Hindle. I was thinking Henderson, but I didn't want to say Henderson, so I said Hindle, which I don't know. What's the initial value? The initial value is the starting value on the y-axis and is always represented by 0 and the number. So a starting value, this is just notes, on y-axis, represented by 0 and some number. That number is the initial value. That's the initial value. So the initial value here would be 5,500. 0 and the number. What does the initial value mean in the context of this problem? Y'all, please don't say it's the starting value. No, no. In the context of the problem, she is buying a used boat. It is not necessarily, well, it could be, but we're not going to say. But this is the amount that she owes. So this is the amount she initially owes. Shout out to Chloe who said that in the first block. This does not represent the payment. Okay? What is the rate of change? Well, the rate of change is the change in y over the change in x. Is how the y's and the x's increase or decrease. That's how you find the change. You look at the increase or decrease along the y's and along the x's. So let me pick another color. So 55 to 5100 is going to give me 400, but I'm subtracting 400. Lord, somebody's at my door knocking. I'm trying to do a video. Now I got to pause the video. The video didn't pause. I know you missed me. Oh, yes, you did. Oh, yes, you did. Where do we go? All right, so subtracting 400 here, subtracting 400 here, subtracting 400 here. Here we are adding 1, even though that didn't make it. All right, stretch you. Yay, you made it. So now the initial value is a change in y over the x, negative 400. So what does this mean? This is the amount of money that she's paying every month. Okay, even though they don't ask what it means, but this is, we're going to write it anyway. Hold up, the mic fell, y'all. The amount of money she pays every month. Y'all know, guess who was at the door? Miss Henderson, not Miss Henderson. Miss Hindle. All right, keep it moving. Don't miss this, y'all. Oh, gosh. What'd I do? Y'all, I keep hitting buttons. Like, buttons keep getting hit. Move out the way. Out of here. All right, we did that already. All right, so it says most animals age more rapidly than humans do. The chart shows the estimated equivalent age for pigs and humans. Y'all, it's supposed to be dogs and humans. Oh, gosh, but I keep forgetting to change stuff when I remake this stuff. Oh, it's the story of my life. Okay, on the graph, provide a title. Okay, clearly it's not pigs, dogs, and humans, but you can say human years versus dog years. We had pigs yesterday. This year we have this time we have dogs. All right, gotta hurry up. And then label the axes. Second block. Got so happy when I said that today. So we have human years on the y-axis and then dog years on the x-axis. So human years would go here, human. I got the free version, so I have to be done in 15 minutes, so I have to hurry up. And so human years, dog years, number. This is where some of y'all get in trouble. Please make sure you spread out the numbers. So when you spread out the numbers here, this is 1, 2, 3, 4 on your X. So please don't put them all here. This is the same graph from yesterday. So every 5 can be 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1. 1, 2, 3, 4, 5. 2. 1, 2, 3, 4, 5. 3. 1, 2, 3, 4, 5. 4. And the same thing here. Every 5 could be 7. All right, and go up. And then you graph the order pairs. 1, 7. The first one is 0, 0. Don't forget, because you'll lose points. I want you to finish this on your own. Okay, do that on your own. Hold it down. POP. I know that's old. All right. The last lesson for describe the relationship with the input and output. Well, every human year is 7 dog years. How could you represent this as a function of an equation? Well, when you come up here and you look at the rate of change, the rate of change is 7. All of these are increasing by 7. All of these are increasing by 1. So 7 over 1. Initial value is right there. So therefore, y'all, I'm writing. Make sure you're writing. I'm writing. Make sure you're writing. When we go here, I might have to make 2 videos because I have a feeling I'm going to run out of time. But it's all for you. So the equation is y is equal to the rate of change times your x plus your initial value. Well, our rate of change was 7. Our initial value was 0. Therefore, our equation is y is equal to 7 times x. And we don't do plus 0. It's understood to be there. All right. I might get done, y'all. Okay, so on the last one, the equation shows the temperatures warmth front after a warm front entered the region after several cold snaps. Okay, so the temperature is equal to 5 plus 3 H, and then day 2 is shown in the graph. Which company has a greater rate of change? Well, I know the rate of change for day 1 is 3. It's with the variable. I'm writing, you're writing. And I know that the rate of change for B is change in Y, not B, this is day 2. Change in Y over change in X. So the Y's change, this is going up. Stop doing weird stuff. The Y's are going up. Stop doing weird stuff. So this is 2, 4, 6, 8. So they're going up 2 every time. So this is not just 2. This is 2, 4, 4. And then this is 2, 4 over 2. So the rate of change for the graph is 4 over 2, which is 2. So which company has a greater rate of change? Well, company, Jesus, Mr. O'Neill, like you didn't change anything. Which temperature, which day has the greatest day? Goodness gracious, day. Has the greatest rate of change. You know I did this fast. It's day 1. I got a minute left. Which company has a greater initial value? Well, the initial value here is 5. Initial value here is 8. So day 2. And in 8 hours, which day would be the coldest day? Well, we need equations for that. So day 1 equation will be y is equal to 3x plus 5. Day 2 equation will be y is equal to 2x plus 8. And we put 8 in there, so that'd be 24 plus 5, which would be 29. And we put 8 here, so that'll be 2 times 8 plus 8. 2 times 8 is 16. 16 plus 8 is 24. So which day will be the coldest? The coldest day will be day 2, because the lower the temperature.